Hello. So we learned two most important theorems in statistics, the law of large numbers and the central limit theorem. So any statisticians would agree that these are the two most important theorems in statistics. Okay. So I prepared three examples that apply these two theorems. So let me show you one by one. The first example is the same example we used before. So we are interested in the distribution of annual income. So we choose a random person and denote a single person's annual outcome as X. And suppose that we know the mean of the annual income is $50,000 and standard deviation is $10,000. By the way, so I only gave you the mean and the standard deviation, but I'm not saying the distribution is normal. Usually, the distribution of income is very much positively skewed because there are extremely rich people which are like several hundred deviations from the mean, right? So anyhow, the distribution of the income is not normal, but in the end, we are going to use the normal distribution due to the central limit theorem. Let's think about this. So anyhow, for now, we are assuming that we know the true mean and true standard deviation for a single outcome. And now suppose that a, say, research center surveys 100 people for simplicity, 100 people, calculate their average X bar, right? So then what we are interested in here is, what we want to say here is the accuracy of this estimate. So I am interested in the mean annual income, but I do not know this number. So instead, I asked 100 people and calculated their average income. So then the difference between this sample average and the true mean, true expectation, is the estimation error in X bar, in estimation error in the sample average. So like for example, I would like to calculate the probability that the economist underestimates the average income by more than $3,000. How likely is that? It is about accuracy, okay? So this is possible. Suppose that we can calculate without observing the 100 survey, right? Instead, we just treat X bar as a random variable, right? Even before asking people, you can calculate that probability. So the probability that the economist's sample average estimate is less than $47,000, which is $3,000 less than the true mean, true expectation. So how likely is that? So first, it goes back to the practice we did in normal distribution chapter. So I do not know, we know that X bar will be approximately normal distribution. So in the end, we are going to approximate this guy to a normal distribution. To do that, we need to know the parameters for the normal distribution, which is given by these two formulas. The mean of X bar is the same as the mean of the single outcome, single income, right? $50,000. So the expected value of the sample average equals 50,000, and its standard deviation is, the single outcome standard deviation divided by square root of n. By the way, the reason why I chose 100 as the sample size is because square root of 100 is 10, which is simple. So you can simply cancel out 1, 0. And then the sample average is, standard deviation is exactly 1,000. So you have the parameters for the normal distribution, and then you can approximate the sampling distribution to a normal distribution with known parameters. So you know everything. So then follow the normal distribution practice. Standardize X bar. So X bar minus its mean divided by its standard deviation. So remember, this standard deviation is calculated already using this formula. So some textbooks use square root n in here. That is not wrong because we already calculated it here, right? So anyhow, standardize, and remember you have to do that in the same way on the other side of the inequality, and then you are going to get -3. So $3,000 below the mean divided by 1,000, divide by 1,000 is -3. So calculate this probability from the normal distribution CDF on Excel. Then you get 0.1%. So now you can say that okay, the average sample average would have some random error, but its probability is like this. So by changing those numbers, you can calculate probability for like any kind of error. So the law of large numbers and the central limit theorem give you how to calculate the error probability. Okay. So by the way, this is the basic idea of how we evaluate the accuracy of an estimator. So, but we are not into the estimation chapter yet. Like chapter 8 will be about the estimation. There are more subtle, more nuances to make it more robust, more rigorous, right? So, by the way, the basic idea is based on the sampling distribution. Okay. And I will stop the video here, even though it is too short. The next example, because the next video will have a separate example, which will be also very interesting. It's about risk pooling or the insurance, how insurance company survives the risk. Okay. Okay. Thank you for watching, and see you in the next video.